So, good evening, class. Today we are going to study about one of the basic concept of physics, that is thermodynamics. As we had switched over to the different portal, it will be easy as of now so as to see and check the various type of formulas which I will be writing and which I will be demonstrating so as to make the subject more clear, and it will render more transparency also. So as the word suggests, thermodynamics, as I had written one statement there, as I had written one word there, it is known as the thermodynamics. So basically, thermodynamics, it is composed of two words. Now, the first and foremost, it is thermo, and second word, it is dynamics. So as I had written the bifurcation of the thermodynamics, and it is stated here that it is basically composed of two words. That is, the first word is thermo and the second word is dynamics. Thermo, as we had already studied, the thermo is related to the mainly it is related to the heat energy. Dynamics means it is in motion. Then when the heat is in transit, we can say that it can be converted to work, or work can be converted to heat. So there is certain relationship between heat and work. And so in thermodynamics, we are basically dealing with the relationship between the heat and work, how heat and work are closely related with each other, and how the transformation can be done between the heat and work. So, mechanically, we will be proceeding further slowly and mechanically so that the all concept will be clear and it will be easily understood also. So, as I had already stated that thermo, it is meaning of the it is clearly indicating that we are dealing with the heat energy. And the dynamics means that it is basically dealing with the motion. So we can say that when the heat is in motion, it is you can say it can proceed further for the work also. So when the heat is in motion, it can be converted to work, or work can be converted into heat, vice versa. So basically, we will be dealing with heat energy and work, and what is the relationship between the heat energy and the work. Whenever any transformation is occurring, heat can be converted into work, and work can be converted into heat. We are dealing with the thermodynamics. And in the thermodynamics, we are approaching towards the very basic concept, that is system. We will be studying about the system, then we will be studying about the type of system. So basically we will be proceeding slowly and mechanically. Understood? So system. So system, it is basically a point or space in the region which is under our focus, which we are dealing with. It is a point. Suppose in the Cartesian coordinate, we can say that a system, it is basically confined to a particular point which we are focusing on, upon which our focus is there, or it is a confined space, or it is a limited space on which we are focusing. So basically a system, it is a point or region in space on which we are focusing. So we can say that it is a point or region in space, region in space. So now we are dealing with the type of system. Basically there are various type of systems are there in the thermodynamics. Under consideration, we can say that systems are basically classified as closed system, open system, and isolated system. So when we are dealing with a broad classification of the system, when we are dealing with the broad classification of the system, It is basically termed as, first is closed system, secondly it is open system, and third it is isolated system. So we will be seeing all the type of systems slowly and mechanically. First of all, we are switching over to the closed system. As far as closed system is considered, so in the closed system only mass transfer, only energy transfer can takes place, but no mass transfer will takes place. In the closed system only energy transfer can takes place across the boundary, but no mass transfer can takes place. That is, only heat energy we can feel that there certain heat is there. Suppose we are heating, for example, we are taking the example for the closed system. Suppose we are heating a iron rod, and we had kept one you can say heating object at one end of the iron rod, and after some time we are observing or we are feeling that the other end of the rod is also getting hot because of the heat transfer. So that type of heat transfer is basically the conduction, in which the particle will not leave their position, they will oscillate or they will vibrate in their own position only, and they will transfer their heat on account of their vibration. So in that case only energy transfer is taking place, but no mass transfer is taking place. So that is basically the closed system, a system in which energy transfer is taking place but no mass transfer is taking place. Secondly, it is open system. As far as open system is considered, in the open system both energy as well as mass transfer can take place. So mass is something, anything that is having some anything which is having some weight, or which is having some properties is defined as mass. Anything which occupies space or which is having some weight, it is termed as mass. So in the case of open system, whenever we are dealing with the whenever we are seeing the system with a thermodynamics point of view, in that case, in the case of open system, both energy as well as mass transfer will takes place. Both energy as well as mass transfer will takes place. So that is basically the. So whenever we are taking the example of the open system, suppose we are warming a mass of water in the kettle. In that case, we are observing through the mouth of the kettle both water, it is converted into the steam, it is coming out of the system, and the heat, we are observing the heat also. So in the case of open system, we can say that both energy as well as mass transfer is taking place. Third is isolated system. In the case of isolated system, neither energy nor mass transfer can take place, and it is very you can say it is a very sophisticated system. Suppose in the case of the thermos flask, we are keeping a mass of water, and it is and we had warmed that water prior, we have warmed that water, and after that we had keep it in the thermos flask. In that case, that particular mass of water will retain its property, it will be warm, attaining the same temperature, because in that case there will be no heat loss through conduction, convection and radiation, and no mass transfer will take place. So we can say that it is an example of the isolated system. So it is an example of the isolated system. So we had dealt about the thermodynamics, and we will be revising some part of the topics which we had already discussed. Thermodynamics, when we are bifurcating this word thermodynamics, it is composed of two words, that is basically thermo and dynamics. That is, heat is in transit. Whenever heat will be in transit, it will be converted to work, or work will be converted to heat, vice versa. So we can say that thermodynamics, it is a branch of science which is basically dealing with the conversion of heat into work and vice versa. And post thermodynamics, we had studied about the various type of systems. Prior to that, The definition of the system is system, it is a point or region in space which is under our consideration or under our focus. And the broad classification of system is as follows. It is basically classified as closed system, open system and isolated system. In the closed system, we can say that it is a type of system in which only energy transfer can take place sorry only energy transfer can take place across the boundary, no mass transfer can take place. In the case of open system, both energy as well as mass transfer will take place. In the isolated system, neither energy nor mass transfer will take place. As far as example is considered, I had already elaborated examples mapped with the systems. So moving ahead, we will be studying about the adiabatic process, and I had switched over to the different portal, so that I can write all the statements and it will be clearly visible to all our viewers, and secondly to all our students also, who is attached with this, who is induced with this class. It will be easy for them also to understand. So we are dealing with the adiabatic process. Regarding the adiabatic process, as the word suggests, I will just write it down. Adiabatic process. As the word suggests, adiabatic process, it is a type of process in which the heat transfer is null or heat transfer is zero. That is, we can say that is dq is equal to 0. In this case, at any point, if the adiabatic process is carrying over or it is going over or it is underway, in that case heat transfer across the boundaries will be 0. So that is the mathematically stating, we can say delta Q is equal to 0. So that is basically the definition of the adiabatic process. Now we will be saying some of the terms which is basically which is the you can say which is the base of the thermodynamics. The first we had studied about this. First we had studied about the system, and now we will be studying about the various type of. We had already studied about the various type of system. Now we will be saying first it is system. System, it is a point or region in space which is our consideration. Secondly, we are going to learn about the surroundings. And I am drawing the schematic image of the same. Suppose it is a system. Already stated that it is a point or region in space which is under our consideration. So outside the circumference of the system, whatever it is remaining here, it is the surroundings. So we can say that the outside the boundary of the system, whatever entity it is present there, it is termed as the surrounding. And as far as universe is considered, it is the summation of system plus surrounding. It is the summation of system and surroundings. So that is basically the three basic terms which forms the base of the thermodynamics. The first is system. It is a point or region in space which is under our consideration, which we are focusing. Surrounding, except the system, whatever is space, whatever entities it is present, it is known as surroundings. And as far as universe is considered, it is the summation of system and surroundings. So that is basically the three terms which we had already studied here. Now we are moving over to the different types of laws of thermodynamics, and prior to that we will see some of the properties of the system. First and foremost, property. Property, it is defined as any characteristic of the system. Suppose if any entity is there which is having some characteristics, that is defined as its property. Any system which is having some characteristic, any system which is having some characteristics, any system which is having some characteristic, it is defined as the property. There are basically two type of properties are there: intensive property and extensive properties. First and foremost, intensive properties. Intensive properties are those characteristics of a system or an entity which is independent of the mass. It will not depend on the mass, it is independent of the mass. Suppose temperature, pressure, and all the specific properties, these are intensive properties. Intensive properties are those properties which are independent of the mass, which will not dependent on mass, independent on the mass. And extensive properties, as far as extensive properties are considered, extensive properties are those properties which are dependent on the mass of the system, dependent on the mass of the system. So that is basically the two type of properties, as I had already elaborated. Any characteristic of any entity, property is defined as the characteristic of the system. So if there is any characteristic is there, it will be considered as its property. Switching over to its classification, the broad classification of property is, it is basically classified into two types: intensive property and extensive properties. Intensive properties are those properties which are independent of the mass of the system. Suppose we can say temperature, pressure, and all the specific properties in which we are dividing a certain quantity by mass. Extensive properties are those properties which are dependent on the mass. Suppose force, we can say force is equal to mass into acceleration. In that case, it is an extensive property. So that is basically we had defined properties, the characteristic of properties in nutshell. So we will be switching over to the one of the important topic in thermodynamics, and it will form the base of the thermodynamics, that is laws of thermodynamics. Today we will be covering the first law of zeroth law of thermodynamics. In the next class we will be switching over to the different laws of thermodynamics, and it will render more transparency and it will elaborate all kind of ambiguity if it is incurred. So we will be switching over to the zeroth law of thermodynamics. First and foremost, we will write here laws of thermodynamics. Laws of thermodynamics. First and foremost, we are dealing with, it is zeroth law of thermodynamics. As the name suggests, there are various type of laws induced with the thermodynamics which are governing different type of principles, and under those principles we are seeing the objects, where its motion, its characteristic, its conversion into work, the heat is in transit. There are various aspects which are interrelated with the laws of thermodynamics. The very first law of thermodynamics is zeroth law of thermodynamics, In the case of zeroth law of thermodynamics, we are basically taking three entities, three bodies we are taking, suppose, and we will be just understanding this zeroth law of thermodynamics using a simple schematic diagram. Suppose it is a system 1, it is a system 2 and system 3. So suppose there are three bodies are there, system 1, system 2 and system 3. We can entitle this system 1 as body 1, body 2 and body 3. We will just entitle this system as body 1, body 2 and body 3. So there are three systems are there, body 1, body 2 and body 3. In the case of zeroth law of thermodynamics, we are basically dealing with a thermal equilibrium. As the name suggests, thermal equilibrium, it is a state of two bodies in such a way that there will be no temperature difference will be there. Both the bodies will attain same temperature when kept in close contact with each other after some time. So in the case of zeroth law of thermodynamics, we are just making it more comprehensive, elaborating with the help of three bodies, the body 1, body 2 and body 3. Suppose body 1 and body 2 is in thermal equilibrium with each other. It means that there will be no temperature difference between body 1 and body 2. Second case, if system 1 and system 3 is also in thermal equilibrium with each other, we are denoting with a sign, it will make our concept more clear, it will render more transparency. Suppose these two bodies are in thermal equilibrium with each other. Similarly, these two bodies are in thermal equilibrium with each other. There will be no temperature difference, no heat flow will be there. So in that case, if system 1 and system 2 is in thermal equilibrium with each other and system 1 and system 3 is in thermal equilibrium with each other, similarly system 2 and system 3 will be in thermal equilibrium with each other automatically. So we will be denoting with sign, it will be like this. So this is basically the root statement of zeroth law of thermodynamics. In that case, we had taken the three bodies, we had kept the temperature same for body 1 and body 2 and body 1 and body 3. Automatically body 2 and body 3 will attain the same temperature. So they will attain the thermal equilibrium after some period of time. So that is basically the zeroth law of thermodynamics, which states that suppose if there are three bodies and body 1 and body 2 will be in thermal equilibrium with each other, body 2 and body 3 is in thermal equilibrium with each other, and similarly body 1 and body 3 will be in thermal equilibrium with each other. So system, we had already stated with the help of a schematic diagram, system 1 and system 2 is in thermal equilibrium with each other, that is there is no temperature difference is there. System 1 and system 3 is in thermal equilibrium with each other. Similarly, after some time, system 2 and system 3 will be in thermal equilibrium with each other. So that is basically the very first law of thermodynamics, entitled as zeroth law of thermodynamics. So we had studied about various type of concepts today. First and foremost, we had studied the definition of thermodynamics. Secondly, we had switched over to the system, the very base part of the thermodynamics, a point of reason in space, which is under our consideration, type of systems, surroundings, boundaries, properties of the system, intensive and extensive properties, and laws of thermodynamics. That is basically the zeroth law of thermodynamics we had studied today. And in the next class, we will be seeing the next law of thermodynamics, that is entitled as the first law of thermodynamics. That is basically the law of conservation of energy. And if any problem is there, if any issue is there, anyone can comment in the comment box. As soon as I will see the comment, what is the issue, what is the error what is the problem we are facing, and I will try my best to resolve the query within the stipulated time as soon as possible. So thanking you for the day today. A very good evening.